So we're continuing with limits. This is going to be a long time that we're going to spend in limits. It'll probably, this is just one of the big main ideas. So we're going to evaluate the limits. This is going to be part 2 that we left off from last week. So remember when we have a limit that maybe goes with a denominator of 0, we kind of looked at factorization, like factoring out those two pieces that would kind of sort of help that move along. So we're going to look at a different thing that we'd have to do, which is going to be rationalization, which may have to, you're going to have to multiply by the conjugate. So we'll look at that in just a second. So we have the graph of the square root of x plus 1 minus 2 divided by x minus 3. So obviously, since the denominator is 0 at x equals 3, that's where that's going to not exist. So we can find this limit analytically. So remember, if you have this analytically, algebraically, kind of go hand in hand. But if you have this on a part of the test where you can't use a calculator, you couldn't look at the graph. Okay, so if you can, just look at the graph and estimate that from there. So what we're going to do here, so we're going to multiply by the conjugate. So that's going to be the square root. We're going to multiply by x, the square root of x plus 1 plus 2 divided by the square root of x plus 1 plus 2. So remember, what we're doing here is that all this is doing is we're multiplying by 1, okay? Because anything divided by itself is going to be 1. And when I multiply by 1, I'm not changing the value of anything. So what happens there is that I am going to get the limit as x approaches 3 of x plus 1 and then plus 4, minus 4. And then divided by x minus 3 times the square root of x plus 1 and then plus 2. Leave that all the way out. And then if you'll notice, this is really nice, that this top part becomes x minus 3, which that would mean then I have a numerator and a denominator, common factor of x minus 3. So these divide out. Don't say cancel. Divide out. And so then I'm left with the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. So then I can sub in now 3. So I would have 1 divided by the square root of 3 plus 1, which is 4, plus 2. So the square root of 4 is going to go to 2. So this whole thing goes to 2. And so I'm left with 1/4. So you can see there that that's going to approach, that whole is at 3, 1/4. So now let's look at a piecewise defined function, and we're going to define each piece, and then we're going to look at the limit of those. So the first piece is going to be, I'm going to write it in purple. That's going to be this piece right here. And it's going all the way up to x is less than -3. It's not including 3. And that is going to be negative x minus 5. That's that line there. And then on the parabola piece, it's just a regular, it's x, plus 1 squared minus 6. And that goes from -3 is less than x is less than or equal to 2. And then at 2, it looks like we're going to have, negative 1/2 x minus 1. And that is going to be x is greater than 2. So it's not equal to 2 because there's that hole there. So now let's look at what happens as the x approaches 2 from the right. It is going to be approaching -2. And then the limits. Okay, so if we were going to do this algebraically, you would want to plug it into that bottom equation. So I'm going to plug that in to this bottom equation. I'm going to plug in 2 there since those are values that are greater than 2. That's where you would plug that in. So you would have negative 1/2 times -2, and then -1. And so, therefore, that's where you would get -2 from. So then the limits as x approaches 2, just to regular, well, this is going to be, does not exist, because remember, as it approaches the left and the right, it's high-five misses. So that does not exist, since the limits are not equal. So the limit as x approaches 2 from the left is not equal to the limit as x approaches 2 from the right. So you want to get really comfortable with writing like why. So why does this happen? Because on your free response, you're going to have to communicate where you get each piece. All right, so the limit as x approaches -3 from the left, so that I'm going to use this middle parabola equation, okay, because that is going to be, no, it would not. Sorry, from the left is going to be numbers that are less than, so I'm going to use this one right here. So this is going to be -3 minus 5. So this becomes -2 here. And so then as x approaches -3 from the right, that's when we'll use the parabola piece here. So this is going to be, there we go, -3 plus 1 squared minus 6, which is going to give us -2. And then the limit as x approaches -7. So since -7 is less than -3, I'm going to use that first equation, which is -7, and then -5. So that's going to give me a +2, and I can kind of verify that on the graph there. And then the limit as x approaches -1 is going to be the parabola one as well. So I am going to end up with -1 plus 1 squared minus 6. And so therefore, I'm going to get 0. So this is going to be -6. All right. So just kind of plugging those in with that piecewise defined, just trying to figure out which equation am I going to plug it into. Oh, we got a lot to go. All right. So let's talk about the limit as x approaches -2 from the left of g of x. So I'm just going to plug that in real quick. So that's going to go into ones that are smaller, less than, so this top equation. So I'm going to have 2 times -2 squared, and then plus 3 times -2, which is going to be a +2. And then the limit as x approaches -2 from the right, so that's going to be -1 times -2 plus 1, which is going to be 2 as well. So the limit as x approaches -2 of g of x, even though we have a piecewise defined function, is still going to be 2 because these two limits are equal. So it does exist. So the limit exists because the limit exists because the limit as x approaches 2 from the left is equal to the limit as x approaches 2 from the right. All right, so now we're going to look at these. So here's what I'm going to do. I'm just going to kind of jump around from these, and so I'm going to only talk through a couple of them. But the rest of them, I'm going to work them out and basically speed up the video so you can still see the thought process of it, because we have a ton here. So I just want to make sure that we kind of go through what you need, and I am not making a 30, 45-minute video going through each limit. And I hope you appreciate that. So the first one is just direct substitution. So this is going to be the natural log of e divided by 2 divided by e, which ends up being 1. I mean, not divided by 2 times e, so this would be 1 divided by 2e. So even though this is asking for the left side, since this is a quadratic, remember it's continuous, so it doesn't matter which side we're looking at. So I'm just going to plug in 5 for both of those. All right, so I'm going to talk through this trig one here. So I'm going to rewrite this as the limit as theta approaches pi for sine theta squared, and then I'm going, and then plus 2 cosine theta. So rewriting that, and then I'm going to plug in substitution. So sine of pi squared plus 2 times the cosine of pi. So the sine of pi is going to be 0. So this is 0 squared plus 2 times the cosine of pi is -1. And so therefore, I'm going to get -2 here. All right, so we have I'm just going to go ahead. This is just a direct substitution. So I'm just going to substitute that in, and then I'm going to show you the simplified form of it. But it's kind of a little bit more involved. So I'm not going to talk through it. I'm just going to work it out. So we end up with -9 square root of 3 divided by 25 pi squared. Okay, so just want to make just a quick note here that this is going to be the sine of 5 pi over 3 divided by the cosine of the same thing. Okay, so you have to split that up. So almost every single time you see tangent, if you have to do some simplification, you're going to have to split it up to sine over cosine. The next one, we're going to have to use factorization and factor out some things and then help us to move forward from there. So that's it for E. On this next one, we're going to have to use a difference of squares. So there's not anything else I can do with this one. This is just going to be does not exist. And I know that that's frustrating, and you're saying, well, when do I know and when do I not know? You'll get the feel for it a little bit better as we move on, but this one is kind of tricky on that one. All right, so now we have a difference of cubes. So I'm going to show you just a quick reminder on how to factor that. So since 8 is a cube, x is cubed, and then 27 is a cube, you're going to take the cube root of those, and that's 2 and 3. So this is going to end up being 2x minus 3 times 4x squared plus 6x plus 9. So you have to take the first term here and square it. You take the last term and you square it, because that's going to be like if you were to square 2x minus 3, if you were to square that, then you would end up with the 4x and the 9, and then you take the middle two and you just multiply them together. On H, we're going to have to multiply by the conjugate, okay? So I'm going to go ahead and talk this through. So I'm going to multiply by the square root of 2x plus 5, 5 plus 1, got a little ahead of myself, divided by, I said equals, this is supposed to be times. And then the square root of 2x plus 5, and then plus 1. I'm going to multiply the top and bottom by that. So then I'm going to end up with 2x, the limit as x approaches -2, of 2x plus 5 and then minus 1 is going, and then divided by x plus 2 times the square root of 2x plus 5 plus 1. All right, so I am going to go ahead and simplify the top and the bottom. So I'm going to get the limit as x approaches negative 2 of 2 times x plus 2. So this became 2x plus 4. Okay, and then I'm going to have x plus 2 times the square root of 2x plus 5 and then plus 1 in the denominator. And then these two divide out. Don't say cancel, remember. So I can now substitute in. So I'm going to have 2 divided by the square root of 2 times negative 2 plus 5 and then plus 1. So this is going to go to 1. So 1 plus 1 makes 2. So I end up with 2 divided by 2, which is 1. All right, so this one's going to be a little bit different because we're still multiplying by the conjugate, but we have it flip-flopped. So whenever it gets a little bit different, I guess you could say, is where I'll chime in, but I'm just going to work through it so that way you can kind of see how this goes. So here's where it gets a little bit tricky. From right here, you're going to think, oh, I just wish that this was x minus 1 on the bottom and x minus 1 at the top. Well, they don't necessarily divide out and make a positive 1. They actually divide out and make a negative 1. Okay, so then that's going to change the sign of everything at the top. So that really makes that like a negative 2 up there at the top. And so then we can go from there. So we get negative 2 there. Okay, so I'm going to logic through this one because it is a little bit more involved, and I want to talk it through so that you kind of sort of understand where this is coming from. So I am going to multiply the both top and bottom by 1. So what I'm going to do here so that I have a common factor, I'm going to multiply this one by x over x. That's an x. And then I'm going to multiply this one by x plus 2 over x plus 2. So therefore, I am going to get x over x times x plus 2, and then plus 1, basically x plus 2 over x times x plus 2. So now do you see I have a common denominator? And then all divided by x. So then I'm going to come across here. I'm going to multiply by 1 over x over here because I'm going to get rid of that denominator. Remember, you flip and multiply. So then I'm going to get the limit as x approaches 0 of, see, this is going to be 2x plus 2 over x times x plus 2. So then I could factor out the top 2. Okay, so I'm really not, this is going to give me the numerator is going to be 2, but the denominator is going to be 0. So this basically gives me 2 over 0. I've tried everything I can. So this one is kind of like that other one. This is going to be, does not exist. Okay, since we can't, since we have tried factorization, there's nothing else we can do, then the limit just doesn't exist. And that's going to happen. All right, so we're going to have to factor here. That's our first step. So we're just going to plug, since we couldn't plug into, we're just going to factor here. So this is going to be the limit as x approaches 2 from the right of, let's see here, this is going to be 3x plus 1 times x plus 2 divided by, I'm going to have x plus 2 times x minus 2, because that's a difference of squares. These divide out, and so I'm left with 3x plus 1 over x minus 2. This is going to end up, so I still would get a 0 in the denominator, okay? But since I'm looking at it from the right, I'm going to come over here and do my little table like we've done before, where I'm going to pick a number that's slightly bigger, so 2.1, and that's going to be a 3x plus 1 over x minus 2. So then I'm going to, when I plug in 2 plus 1, 2.1, I'm going to get a positive value over a positive value, which is going to give me a positive. So this is going to be positive infinity. So I don't know if you remember that. That was actually from the last lesson that we looked at just recently. So that's what we're going to look at here as well. So there's nothing I can do to start factoring. So I'm just going to just basically look at the table. Okay, I'm gonna pick it to a value. So my x is like 3.1 of 2x plus 5 over x minus 3. So that's still going to, so if I take 2 times a 3, that's going to be a 6 plus 5. So that's always going to be, I'm always adding. Positive plus positive is going to be a positive. And then the bottom is going to be a positive. So this is going to be a positive. So this is going to be a positive infinity. So if you can't multiply by the conjugate, you can't simplify like through trig identities or anything like that, and you can't factor, and you can't still plug it in, you've got to result to this. All right, and so then if 3 is from the left side, here I'm going to make my table. So when x is like 2.9 for 2x plus 5 over x minus 3, then I'm going to end up with a positive on the top, but a negative in the bottom, which is going to be negative. So this limit is negative infinity. So lots of things. We went through lots of things. So the main thing that we learned today was the multiplying by the conjugate. So if you have somewhere where you have a square root, you're going to have to do that, whether it's first or second term. Then you have factorization. So you're going to have to factor. So you need to look for one of those two things. And then if one of those two things can't work and you still can't just straight substitute in, that's the other one, then you're going to have to resort to filling in the table of looking right or left. Okay. So that way you can kind of sort of check and see where you're at. All right. So that's it for limits, finding it by hand just for a little bit. We're still working through some. We've got some other things we've got to hit on, but then we're kind of getting through to the heart of limits.